Hi and welcome back to the lab. And today we look here at the brand new TOPDON TC004. So that is a brand new thermal camera with a remarkable feature set. And I'm really curious what this camera can do. So let's have a look. Okay, but first let's have a look what we have here in the back. And yeah, okay, so a carry bag, very nice. Calibration certificate and a product certificate and a little handbook, very nice. And we have a power adapter here to recharge the battery, and we have USB cable. We have here for making photos a little 16 gigabyte card, and at least our handheld TOPDON. Very nice. Okay, so let's go into it. So why was I talking about remarkable feature set? So we have top features where or how we can evaluate an infrared cam. I mean, of course, first of all, it is nice to see and to understand what the touch and feel is. And I can definitely say that it is a good feeling. So it looks like quality build. So there is definitely nothing to complain. And we can put it here on a tripod to hold it in position. So therefore, that is the first what you really want to know when we talk about, you know, something like a camera, an infrared camera like this. And you see, first we start with the booting time. So there is a lot behind this technology, and you see it takes a while until it is then ready to go. But again, when we talk about an infrared camera, we have, from my point of view, let's say 4 or maybe 5 features which are crucial for its performance. And we all know that thermal cameras was really expensive in the past, and this camera now has really nice features for a reasonable price. So let's talk about infrared sensor resolution. Let's talk about NETD, so which is finally the thermal sensitivity of the sensor here. We need to talk about frame rate, and at least this is a mobile unit. We need to talk about battery and battery life, because when we are using a mobile unit where we walk around, you know, we need to talk about standby and operation time. And of course, a thermal camera like this is not only for one application. So there are a variety of possible applications. I mean, we will talk here a little bit about how can we use it in electronics, because that is what we are doing here at the TRX lab, right? So we are working on radios, but the applications are, you know, it is a wide variety, and therefore it makes sense to show what a camera like this can do for you if you are working like me in electronics. Okay, so before we try to evaluate this camera, before we see what pictures this camera is producing and whether these pictures are helpful to what we are doing or not, let's talk a little bit about the features to understand if that what this camera is delivering is good or is it bad, and what is behind all these features which we find everywhere. But you know, all these features do not mean nothing if you do not really know what's behind it. So let's start with resolution, because that is very well known. So we know it from a normal camera, from a mobile phone. So we are talking about the display resolution, and it is not more than how many pixels the camera itself has to display what it should. So look here, if you only have very, very little dots, then in this case 4 dots, so you do not see nothing. If you have let's say 10 dots, well, it is not much better, but 10 by 10 it starts to getting better until you come with a higher resolution to a complete picture and you really see what it is. And as more pixels you have, right, the image is getting better, it's getting sharper, and the resolution shows you really what is behind what you are filming, right? Here you may see it even better. So that is a person, right? And with a low resolution you see nothing, and as better the resolution gets, as better is what's on the picture. And simply because of that, it is important to know what is the resolution of the thermal sensor here. And in our case, it is 256 by 192. So that means this camera is capable to display 49,152 pixels, which means what we are trying to capture here has a good resolution, and the pictures we see are very, very easy to see and to understand what's behind it. So there are a lot of cameras on the market which has less resolution, infrared sensor resolution. So again, this one is 256 by 192, and you have a lot of, they only have 120 by 90 or 80 by 60. So okay, it always depends on the price, but this camera is compared to let's say FLIR or FLIR cameras, a really good camera on a budget, and as I said, with a very, very important and interesting feature set. So 256 by 192 with 49,152 pixels is really a good value for a camera like this here. And what I really don't understand is the fact that you very seldom hear something about the NETD, which is the noise equivalent temperature difference. So with other words, and that is the thermal sensitivity. And I only hear people talking about the ER sensor resolution. I mean, sensor resolution is important, and we have seen it before when we discussed the IR sensor resolution. But without a good NETD value, then it is still a problem and you do not get good thermal images. I mean, even here on the box you see 256 by 192 high resolution IR camera. I mean, yes, that is true, but you need to go here in the small printing, and there you find the NETD, and that is below 40 millikelvin. 40 millikelvin. And now that is the point. What does it mean? Is below 40 millikelvin good or not? So what can I do with this feature and with this information? Okay, so it might be that the resolution of my camera here where I'm filming with is not able to show the details, but maybe this here gives you an idea. So we have here a picture, same temperature, left and right. So this camera is a 200 millikelvin camera, and this camera is able to do 0.2 degree C steps until it gets noisy. And here on the right side it is a 100 millikelvin camera, which is able to do the same until to 0.1 degree C. And what you see is independent now from the resolution, the IR resolution of the camera. You see that here on the left it is very, very noisy because the sensor is not able to go below 0.2 degree, and it starts to becomes noisy, whereby on the right side it is much better, so the picture itself is more clear. And you see as lower the Kelvin value is, as better our picture becomes at the end. So that means the right picture, the camera can therefore resolve up to 0.1 degree Celsius, which is, as you can see already, a better picture. And what we see as well, as lower here our millikelvin value is, as better, because the thermal sensitivity is getting better and we have less noise. So that is what it is. And then we go back here to our TOPDON camera. We have below 40 millikelvin, and that means that the thermal noise is really, really low, so that can resolve below 0.05 degree C. So, and that is really a good noise figure, if you like. And therefore in the past below 40 millikelvin was already something which you only find in very expensive cameras. Therefore many cameras on the market was not far below 100 millikelvin, so that was already very, very good. Now we may be able to imagine why it is important to have both with a good value. So the IR sensor resolution on one hand, and on the other hand the NETD. If both are in a good level, then you have good and clear pictures, and we do not get a kind of blurry. And that was what we had in the beginning of IR cameras. So we only get a blurry dot, but it was not really possible to distinguish what do we see there. So that might be here an early picture, low resolution and a bad NATD, and you do not really know what you're looking at, so that is blurry, and yeah, so that was not really helpful. And today that all becomes much better. And not only very expensive cameras do have such good features. Well, and the very next here on our list is for sure the frame rate. And that is at least, you know, the update, right? So the update, what our camera is able to deliver. Let me see if we can demonstrate it. So when I move here with the IR camera over the objects here on my bench, you see that it is very fast updating, and you know, the objects here on the desks are really or it is changing. The update is fast enough that the camera is following with the speed I'm moving the camera. So that is what it is. And if you have a low resolution, not a low resolution, sorry, a low frame rate, then you know you cannot really move your camera and expect that you have a nice update, a picture update. So then it would take really long. But this camera has 25 Hertz, and that is reasonable good. Many, even much more expensive cameras only have 9 or 8 Hertz update rate, and this here has 25, and you can see that I can move the camera here, and we see the objects quite well while I'm moving here. And of course the fourth, which I personally think is important, is the battery. And here that is a rechargeable battery inside, so we can charge it here over our USB-C port, and with one fresh charged battery, so the camera can be used for 12 hours. So that is what our specs are telling us. And the battery itself is lithium ion, and that is 5,000 milliampere hours. Good, as I already said, for 12 hours operation. Well, and after we have now a little bit knowledge what is behind all the features and what do I need to compare cameras to each other, and to compare prices, and to understand what it means if a camera costs $200, 400, or even $2,000. So where are the differences? And now, with knowing what the resolution, the sensor resolution is, the NATD and the frame rate is, you may be able to understand and to distinguish between the different features and what other sellers and products deliver with a price So that might now much easier to you, and yeah, therefore we really can go now into the camera itself, and we can test how the top-down is performing on our radios, so performing on the work we are doing. And therefore that is then of course the second step and the second part of our video. Now that we can understand the given specifications in the manual, we should be able to predict a little bit what we expect looking into the IR camera. So many of you knowing that I'm using here the little FLIR 1 Pro camera for doing the job here on the bench. And I mean, especially the Pro is definitely not a bad product, but to understand the differences between what we have here on the TOPDON and the FLIR, let me tell you some specs. So, for instance, the thermal resolution is 160 by 120 compared to the TOPDON with 256 by 192. And on the other hand, the NETD, so that was below 40 here with our TOPDON, and with the little FLIR it is around 70. So generally spoken, that is already a good camera, so that is not bad. So you would expect to get good pictures from the little FLIR as well, and I can assure you we do get good pictures. Then the third feature where we talked about in comparison to the TOPDON is the frame rate, and we have with the little FLIR here only 8.7 Hertz, and that is a little bit slow because if you move very fast the camera, so the frame update can't follow fast movements, right? Anyway, let us have a direct look when we take the TOPDON and the little FLIR, and we can compare what we see. Okay, so let's start with some devices I've here on the bench to see some differences, just to understand what we are doing. And remember, we only using the IR camera, so there is no additional optical camera used. It is only the IR camera, and that means we need both a good resolution on the IR sensor, and secondly a good NETD, which is, as we learned, the noise resolution, if you will, of our sensor itself. Okay, and we start here with our little FLIR, and what you might notice is that we get a rough idea what we see, but everything is not so precise that we really would be able to see details, right? Okay, and now the TOPDON here, and I hope you can see the difference that we have much more details here on our screen. I mean, once again, remember that is only the IR sensor, which makes it really difficult to display what we are looking at. And I mean, we can see the details which with a very early camera we wouldn't see. So we would only see a color blob, and that's it. And here we can definitely see quite a lot details what we are looking at. Well, and especially in the past, when it all starts and the IR sensors were not so good, they put a second camera, so an optical camera, to the system, and that is what the little FLIR can do as well. And you see now we have both. So we have the IR picture and our little normal optical. And now you see much more what you're looking at. The problem is when I go closer and closer, then it comes out of calibration, and you know, it does not really fit together. So when I use the little FLIR, I always switch it off and only go back to IR, and with only IR I can better see when I have somewhere a hotspot. But when I have, on the other hand, more details by simply using here the infrared camera, so that is really, really great. And together with our TOPDON camera, we get a program where we can watch and analyze photos we have stored in the camera. And I have here some of those images, and you see even here, so that is you see a little power supply, and that has been taken out of the wall plug. And what you see here is that we have really a clearer picture only through the IR camera. So that is really nice. And over the USB cable here we can use our infrared camera to bring the picture here onto the PC. And you see we can moving around, and so that is really nice as well. Okay, and now we look at what we are normally doing here at the TRX lab. So we are working on radios, and well, so I have here an example. So we have a lot of really small parts, SMD parts of course, and we have two points where we should focus on, and that is first here our processor, which is operating the radio, and then we have here, for instance, a voltage regulator. So this both parts are very interesting, and so let's go over to our IR picture and let's see what we can identify. Okay, and the unit is switched off. The problem with all infrared cameras is that we have reflections. So even here we have reflections, and that is not any heat. So you always need to use your IR camera with some intelligence. So because all what we can see here are non-hotspots. However, we will see if that will change. I mean, are we able to identify when we are getting heat from a component which is heating up? Once again, our unit is switched off. Down here we have our processor, and over here we have our voltage regulator. For the moment it is hardly possible to see details here on the board, only with the IR camera. But we should not forget that we are really dealing here with very, very tiny components. Okay, now let me simply switch on the unit, and what you always need to do is you need to see first where all the reflections are, and when I'm switching on the unit, do we see any differences? And now I switch it on, and aha, so what we can clearly see here, we have a hotspot, and that is our, and I go down a little bit more, so that is finally our MCU, which is on 29 degree when I have switched on the radio, right? And what we can see else there, and that is with 41 degree already working, so that is our voltage regulator. And yes, you see when we have here the radio switched on, then the details become more visible. Without the unit switched on, so when I go here in between, that might be a little difficult to see the details, so that is not really sharp, and it is hard to identify. And it might be even, and I'm really convinced this camera do have a good IR sensor resolution and has very, very good NETD, a much better NETD than our little FLIR. But you see, dealing here with all the little components, it is a little bit difficult. Therefore, it would good to have an additional camera, so an optical camera, and where both pictures get overlaid, so how we have seen it with a little FLIR, then it is more easy to identify all the little details here in between. But other than that, I mean, we can clearly see where we have hotspots, and that means on the other hand we will be able to find shorts, because that is what we are looking for when we are using an infrared cam. And if we have swapped out components, we want to make sure that nothing is overheating. So for instance here our voltage regulator with 43 degrees C is really good. If it would show up 70 degree, for instance, then we would know something is wrong. Or if our CPU, our MCU, it is an MCU, is here showing up with approximately 32 degrees C, and that is completely fine, no problem whatsoever, right? However, I think there is another cam. It is not completely launched, I believe, the TOPDON TC005, and it might be possible that the TC005 would be better for applications we are using it for electronics. Okay, so let's do the exact same with the little flare here, and you see it is really blurry, the picture we get here, so that is really not easy to see, but we could switch in the second camera, so the optical camera, which is now switched in, and you can easily see that now, because we have additionally our optical camera as an overlay camera, so we can easily see that now the details are easier to see. When I switch it again off, you see it is really a problem, so we do not see nothing. So that makes clear that the TOPDON has already a very good performance. And now let me simply switch in the radio once again to see what we can see here on the flare. And oh wow, to be honest, I do not. Okay, now we can see it as well. So of course we can see the voltage regulator here, and that is our MCU. But what you see as well, you do not have details. So we only have a blob. So we see there is a hotspot, but especially here our processor is not very good to identify. Let's switch in here our MSX feature, and now we can see it here much better. Let's see when I go now more down, but already now the overlay camera does not match any longer with the infrared camera, and that is what I meant when I said that I always switch off the MSX camera, because it doesn't really help. Now when I go closer, you can see it. Now it is easier to identify that I have a hotspot, and of course the same when I move over here to our voltage regulator. So you see I can see the hotspot, but other than that I do not see nothing. So the performance overall of our little flare here is not really satisfying. And now back to the TOPDON. So that is now the picture we see only through our IR sensor, and you clearly see how much better that picture is compared to the little flare. So we definitely have much more details, and we can clearly see where our hotspots are. And when I go over, we see our MCU is on 34 degree, and that is a much more satisfying picture. However, I think that the TC005 would be better for our applications, where we need to see all the little components, all the SMD components on this PCB to distinguish all the little parts. And therefore, I believe a camera like this, the TC004, with a given performance, and once again I'm really convinced by its performance, and you can see it by yourself, it is fantastic. But having additional to that what we see here, our optical image overlaid, then I believe, especially for our application, that would be gold standard. And finally, what do I think? Yes, the TOPDON TC004 is a very good camera. So it has a very good and a really convincing performance, so no doubt. However, for our applications, as I said, I think the TC005 would be a bit better, but for all other applications the TC004 is great for a great price, so you get high performance for a small budget. So that's it for the day. I hope that was somewhat interesting to you, and you have seen where and how we can use these cameras. And yes, that's it for today. Thanks for watching, and catch you next time. Bye.